Hi everyone. Today we're going to study system of linear inequalities. In particular, we will learn graphing a linear inequality. Here are the steps in graphing a linear inequality. Step 1. Translate the inequality to equation and solve. Step 2. Graph the line as solid or dotted. If the inequality involves the symbols greater than or equal, or the symbol less than or equal, line must be solid, and dotted line if symbols are greater than or less than. Step 3. Use test point, preferably the origin 0, 0, to find the solution region. If the origin makes the original inequality true, shade that region that includes the origin or otherwise. Remember, the solution of a linear inequality is a region. Let us have example 1. Graph the inequality 2x is greater than 8. Step 1. Translate the inequality to equation and solve. It means to say, we're going to change this greater than symbol into equal sign. So we have now 2x equals 8. And then let us solve for x. Let us divide the equation by the coefficient of x, which is 2. So this 2x divided by 2 will give x, and the right side would be 8 divided by 2. And the quotient equals 4. So we have x equals 4. For step 2, let us graph the line. It may be solid or dotted. We know that the equation x equals 4 is a vertical line that passes through the point 4, 0. So let us draw our x and y axis. Let us plot the point 4, 0. And this is the point. Now, let us draw a dotted line because the inequality symbol is greater than. Remember, we use dotted line for greater than or less than symbols. And here is the line, or I should say the dotted line. When we draw the line, we are dividing the space of the rectangular coordinate system into two regions. One is on the right of this line, and it's here. The other region is on the left side of the line. Now, let us have the step 3. Use the origin, the 0, 0, as test point to find the solution region. It means to say, since we have two regions here, one of these regions will be the solution region. That's why we need to use a test point. And this is our origin. And this origin is part of the region on the left side of the line. So, the 2x is greater than 8. Let us substitute our origin values or the coordinates of the origin. And the value of x is 0. So we have 2 times 0 is greater than 8. And 2 times 0 is 0. Greater than 8 gives a false statement. It means to say, when this is false, what we're going to do is to shade the region that does not include the origin or does not include the test point. So here is now our shaded area, which we call the solution region. Take note, since we have a dotted line here, all points on the line do not belong to the solution region. This is our final answer. Let us see example 2. Graph the inequality 3x minus 5y is less than or equal to 15. Step 1. Let us translate this inequality to equation. So 3x minus 5y now equals 15. Then step 2, let us graph the line. It means to say, first let us find the intercepts. For x-intercept, we set y equals 0 and solve. So the equation now becomes 3x minus 5 times y, and the y becomes 0 equals 15. We can simply cancel this 5 times 0, and only 3x equals 15 comes down on the next line. Let us solve for x. We will divide the equation by the coefficient of x, which is 3. This 3x divided by 3 will give us x equals, the right side is 15 divided by 3, and the quotient is 5. Let us write the x-intercept as ordered pair, so we have here 5, 0. Now for y-intercept, we set x equals 0 and solve. The equation now becomes 3 times 0. The x now becomes 0 minus 5y equals 15. 3 times 0 is cancelled out as 0. So negative 5y equals 15. Let us solve for y. We will divide the equation by the coefficient of y, which is the negative 5. So this negative 5y divided by negative 5 is simply y, and the 15 divided by negative 5 is on the right side, and this is equal to negative 3. Writing the y-intercept as ordered pair, we have 0, negative 3. We are going to draw the line by connecting the intercepts. Take note also that we should draw a solid line because the symbol inequality here is less than or equal. Let us keep our intercepts on this side. Let us clear this area because we are going to draw the line. First, let us draw our x and y axis. The point x-intercept, which is 5, 0, is here, while the y-intercept 0, negative 3 is here. Then let us connect. We will draw a solid line. Here we go. This is now our line. Remember also that when we draw the line, we are dividing the area into two regions. This is the first region, and this is the second region. Now step 3, we're going to use the origin as test point to find the solution region. The origin is here. Let us substitute the origin into our original inequality. So 3x minus 5y is less than or equal to 15. Now becomes 3 times 0 minus 5 times 0 is less than or equal to 15. 3 times 0 is simply cancelled out. Also the 5 times 0 and this is 0 minus 0, which is 0 is less than or equal to 15. And this is a true statement. It means to say we're going to shade the region that includes the test point, which is the origin. And this is now the shaded area. And this is what we call the solution region. It means to say all points that belong to the solution region is a solution to our inequality. This is our final answer. I hope you learned something from this video. See you again next time.